We'll get into dimensioning for this chapter. The dimensioning is very important because they can affect on how you dimension in your drawing, can affect how a part is manufactured. Of course, we can dimension an orthographic projection in your 2Ds, and we're gonna use a proper dimensioning method. Alright, so here we go again, our detailed drawing. So this is what detailed drawings look like, So you have your orthographic projection. They're completely look at this, everything, each measurement is dimension in your part, So you have your height and width and then your depth. So this is the part that you're going to manufacture, and this is the 2D drawings of your part. We call it detailed drawing because we're putting complete dimensions right into it, and we also call it the specifications. So we have practiced many times the front, the top, the right side view, So just by looking at it, you definitely know what they are. Your picture is right there, and then your front is here, and your right there, And of course, all the dimensions, each one of them is right in there, You have to take some time to carefully look at it. You can't just look at it and see, you have to really look at it, from here to here, and then this is your circle, There is your diameter, So from this edge to that edge, it's going to be like 0.75. From here to the center, of the circle is going to be 0.50, so and so, okay? But anyway, so this is what we call detailed drawing. So you have two things going on when you manufacture the object, and when you draw the object. So when you draw the object, you're going to dimension with the drawing, scale. And then you don't have to dimension the object, right? Like you're drawing. So there, it's very flexible. When you draw, you can make your own scale, It can be the exact dimension of the object outside. So you can make it half or, Then sometimes if for smaller object, of course, you can make it like 1:1 ratio. For bigger one, you can size it down, right? Depends on how big the part is outside. So the similar dimensions are not required to draw. And make sure you follow our standard, strictly ASME, Y14.5M, 2009, of course. So once again, the same dimension, you don't need it to draw and manufacture an object. So we're going to learn how to dimension in this lecture. We'll get into appearance, we'll get into locating your features, of course, and then the rules. And you should give dimension in a clear and concise manner. And dimension should include everything needed to manufacture and inspect that part that you're drawing, okay? Of course, we suppose you are a designer because you're learning how to draw. Anyway, the most important thing is make it clear and make it concise so they know what to manufacture from your drawing. So how are you going to dimension your part? You can just go and draw wherever you want to draw. You have to follow a standard, and that standard in our field is ASME Y14.5. And of course that is going to be your handbook, and then you're going to follow all the rules right in there to draw. Alright, then we're gonna get into the features of a dimension. So in dimensioning, we use special lines, arrows, we use symbols, and we use text. Okay, so we have arrows right there, lines right there. So these lines are showing like from where to where this dimension is, okay? Of course, we also have like arrows, look at that, to clearly define that measurement is from here to there. And then of course we have text. So all these lines, your dimension lines, your extension lines, yeah, and your leader lines, this is leader lines, yeah. You're gonna draw them continuous, and then you're gonna draw them thin, yeah. Of course, they also have their own specific thickness. Leader lines, there are three, all right. So look at that. This little and right there, it's different from the little and then that little and, yeah. So there are three different leader lines. They end in three different ways. One was an arrowhead, the other one was a little dot, and the other one without anything. Okay? Alright, let's look at the rules. So don't do crossing, yeah, no crossing leaders. Meaning like don't cross this label with that label. You can't cross the leader lines. Don't do excessively long leader lines. Okay, don't like pull this arrow all the way out to here. You can't do that. Yeah, just put it reasonably close, reasonably far from your drawing. You can't draw your leader line parallel to your dimension or extension line, right? Meaning like you can't pull this thing and then make it parallel to the extension line. Yeah, you can pull this all the way down and then make it parallel to this dimension line. Don't do that. And you can make a very small angle to the surface your leader line is labeling. Okay, so here like you have different leader lines. That one's for the outside and this one for the cross section is your sectioning, yeah, layer or the plane, sectioning plane right there. And then we'll take a look at arrowheads. So you draw the arrowheads between the extension lines. Yeah, this is your extension lines. Now we draw our arrowheads in between them. If your space is limited for like big complex drawings, you're gonna put it outside. Okay, see how different we put the measurement right in there. Yeah, we put the measurement outside because of the space limit, even limited space right here, so the arrow's outside. Yeah, because if you put the arrow, then you'll be like getting like head to head. So it's better to show your extension lines with arrow outside for the limited space drawing. Then we'll get into types of dimension. So your dimensions are given in the form of linear distances, angles, and notes. Meaning like you have all the lines, you have all the angles, and of course you also have to put some notes to clarify certain things in your drawings, yeah, to the manufacturer. So you have your linear distances, angles, and then notes. Linear distances are either horizontal or vertical, yeah, but they can also be aligned with a particular feature in the part. We'll see later. Your angle, of course, the angle they usually are between two surfaces, yeah, or between two features of a part. Features are different shape, yeah, in your part or connections. And we use a note to dimension your diameter, your radii, chamfers, your threads, and then all the other features, right, that need to be dimensioned. But that cannot be dimensioned by the other two methods. Yeah, so you have your method 1 here, method 2 there. You dimension everything that you can dimension for horizontal and vertical with your linear distances dimensioning method. You go on dimensioning all the angles with your angle dimensioning method. The rest of them you're going to dimension in your notes method. Yeah. Lettering. Again, dimensioning needs a lot of clear and concise, yeah, but you always have to clarify your stuff to your manufacturer. So you gotta make it legible, you have to make it easy to read, and you have to make it uniform throughout the drawing so they are consistent. So uppercase letters, you're gonna use them for lettering, yeah. Lowercase letter, you're gonna use them when it is required. Yeah, minimum lettering height is like 0.12 inches, so that's about 3 millimeter. Lettering height means the height of your letter, okay? So you're gonna keep it like 0.12 minimum, yeah. Dimensioning symbols, we'll use the symbols, and we don't really use that bulky text, yeah. So we want to make it as precise and concise as possible, so you can throw a lot of text into your into your detailed drawing. Okay, so therefore we're going to use a symbol. So the goal of using a symbol is again to eliminate the need for language translation. So we use the mathematics, yeah, symbol codes, in order to shrink all this bulky language right outside that we speak. Of course, if you use your computer, you definitely need to download your GDT font. Okay. Okay, here are the symbols for dimensioning. Okay, so for diameter, we're gonna use this symbol, your spherical diameter, S, and then diameter symbol, radius symbol, spherical radius, we go SR symbol, reference dimension, put it in the bracket, counterbolt is your rectangle without the top, the countersink is your triangle without the base, and then the number of times or places is your x, and your depth and your deep is going to be with the surface arrow down, and then your dimension of the scale is your value, and then you have a line under need of that value. Okay, and then your square is of course a square shape, little one. Your arc length is going to be with a little flat triangle without the base on top of a value. Your conical taper is going to be your triangle pointing to the right with the horizontal line across it. And then your slope, of course, is a triangle with some sort of angle, yeah, on the top side or base. We should call it base. And the symmetry is going to be look like this. All right, symmetric. This upper little dash and lower little dash is separated by a little longer dash, and they're showing the symmetric symbol. Yeah. So, anyways, you have to get this by heart. Sorry. Okay, let's do a little bit of exercise right here for dimension appearance. So here is our drawing, and you can see, okay, so there is a here, and here is your line right there, and this dimensioning, right, type, your line type is a linear line type, yeah. Then of course your B, see, look at this little one, yeah. So okay, so when you take a look at it, we already say, oh, this is a linear, yeah, dimension type, and your line type is also, of course, we just call it dimension line, yeah, dimension line. And here, see this one, little one right there, yeah. So if you think about that, that's your extension line, okay, extension line right here. And then this line, look at that, see, that's your leader line, yeah. So your line type, dimension, extension, leader. The dimension type right here, that's we call a linear. Yeah, that it is linear. And here your dimension type is a note. Yeah, because that's a note we call it. And here is your angle, of course, yeah, between this plane and then that plane. Yeah, you gotta try to look this plane extended to outside, like imaginary. Yeah, you suppose that this plane can extend all the way out, even though there's no material part in there, of course. So that angle is 40. And then that's your general layout of your drawing, of course. Yeah, all fillets around 5R, yeah, unless otherwise specified. So this means 5R means it's just a radius, yeah, the radius of that circle. So I think you get it. Our simple features. For features, we gotta use methods of dimensioning. Circle again is dimensioned. Okay, look at that. That's your circle. By is diameter. Here, that's your diameter symbol. Your arc. See, look at this. Look at that feature right there. Yeah. Look at that feature. This is a two different feature. One is an arc and the other one is a rectangle. Yeah. So a rectangle is closed with an arc. So that's what you're seeing, like a little window. So this arc, of course, is you will dimension by using the radius symbol. Yeah. Use your leader line. Yeah. And they are type again is note. Yeah. Note here, note here. Noting the arc and then noting the circle. Circle use diameter, arc use radius. Don't confuse. Radius is from the center, yeah, from the center to the circumference. The diameter is from the circumference to the opposite circumference. Okay. Now this is your right side, yeah, view. So for a circle, yeah, you if you look at the circle from the right side, of course, and if that circle is a part of your cylinder, this is what you're seeing. Yeah. Because if a circle has a height, then we will call it a cylinder. Yeah. So make sure you are okay with all of your mathematics geometry. Practice at home, back and forth, top and front, right? Bottom, right side, left side, from the back, please. Okay, here we go. So the depth, right? When we deal with the depth, of course, we have a blind hole here. So blind hole means this is a hole, yeah. It's not like a through. Your hole isn't through in your object, yeah. Your hole is a cut right here somewhere in your object. So there's a blind hole. So you have to put the depth symbol to describe that dimension, yeah. So here's my circle and it's going to end at 15 units. Okay, see that? So when you look at this, you know that you're dealing with some kind of a depth from this circle all the way in to your object, yeah? And it will end at that value, okay? So that's what we're seeing. I have a diameter 10, and I'm gonna go in. So if I look this front view from the side, I would definitely have 15 in, yeah? So you go 15 in and draw, of course. Of course, what type of shape will be identified, yeah, from your whoever designed this product, from the engineer is going to give it to you, and you're going to draw it, yeah. So whether it's going to close, what kind of a type of the end that is, it depends on your engineer. Right now, we're just going to cut straight down, yeah, 15. So if a hole goes completely through the feature and it is not clearly shown on the drawing, the abbreviation through follows the dimension. Okay, what does it mean? I think we got the wrong picture, so let's put it back in. So anyway, what it means is if your feature, yeah, and your hole is not blind but it's through, right? Go all the way across your object. So this hole is not going to stop right there, but it's going to go all the way out. Yeah, all the way out. So at that time, we're going to use a through, okay? Through abbreviation, and you will follow that dimension. I think I should show it to you because this is kind of like the picture that we get from the textbook. It's kind of weird. Okay, so I fix the picture in your textbook. So you put through, okay? So it's like you're completely going through the feature, which is different from that one. Yeah. Okay. So now let's go into another one. So for center, of course, we're gonna use a little small cross. Yeah. So this is showing the center. See your feature? Look at that. That's a little arc right there, meaning you're dealing with some part of your circle. Yeah. So there's an arc. So therefore, there's a center arc. There's a center. Yeah. And so from center to that circumference is radius 30. Yeah. And then we go on to, of course, dimension this center of your radius with a little small cross at the center, and then note it. Yeah, with your, and then symbol your radius r, and then the value of it. Okay. And if your center is not so important, yeah, in your drawing, this is what we do. We just put a little r right there, and then, oh, here we go, there's a radius of this little arc, 30. Okay, and then we just note it. That's it. All right, a complete sphere. Yeah, we're going to dimension it by using the diameter. It's a sphere, diameter 40. So we know that this circle is a spherical feature. Yeah, it's a spherical diameter. And then, of course, here, this isn't a complete sphere. Yeah, because you have like a incomplete sphere, not a perfect sphere. Incomplete meaning it isn't a perfect sphere. Then we're gonna use radius. Yeah, so spherical radius is 30. Okay. How do we know that's incomplete? Because of the feature. Look at that, completely different. Yeah. So from here to here, there's a sphere, but that sphere is fused with other feature of your object. Yeah, which is like, look at this. Yeah, geometry completely different from this geometry. Yeah, that's a part of your sphere, but this is something else attached to the part of your sphere. It is simply saying this arc belongs to a sphere, so you won't confuse it with regular circle. All right, so if you see SR, you're dealing with a spherical arc. Yeah. So here we're gonna put a dimension of the hole. I have a hole, and I'm gonna put a diameter. I'm gonna use a leader line, and we're gonna use a note dimension. I'll put my symbol, diameter, and then I'll put my value. Okay, what's been given to me, specification, of course, from your sheet, and put it in. Oh, that's the diameter, 10 circle. Yeah. Different types of features here in this drawing. We have different types of feature right there. Yeah. Require different methods of dimensioning. So I'll put into a specific dimension to specific features. So you have holes, two holes right here. So holes are dimensioned by giving their diameter again, yeah, and location, of course, yeah. And we are gonna put your circular view right there, yeah, showing the circle's radius, yeah. So I have one circle, another circle representing two holes in my object, okay, and I'm doing it with my view, front view, let's just say, and then I'm going to put all other dimensions to it, from here to here, from there to the first center, second center, and first center. Yeah, is this far away? Yeah, because this center from that edge is this far away, that center from this edge is that far away. If you subtract it, then you're going to get from here to here, yeah, 30. the same thing from here all the way to the end is 70. Okay, so then you know from here to the other end, right? Just subtract it is 20 again. Yeah, so 20, 30, and then 20. Yeah, so that's how we look at it. So just by looking at the dimension, and we of course use a sheet given to you. Oh, draw this one with this specification from your product, yeah, prototype, and you will get a print. You will draw. Oh, okay, from here to here I gotta make 20. From here to here I gotta make 40. Yeah. Well, that's a circle, so I'm just gonna give my node as a diameter 20. Yeah. And I have to label this socket, of course, I use a leader line. So I have to, label the linear dimension right there. So you're going to use your arrowhead, your extension line, and then show it very clearly. Okay? So that's what we want you to do. Cylinder, of course, your right side view, yeah? So cylinder, since you're dealing with the two holes right there, but let's say like if this is like from the top view, okay, or front view, you have to think about, is that a cylinder or is it just a regular circle? Yeah, is this part actually protruding out of the object, or is that part stuck into it? Yeah, this little feature stuck into it inside. So you've got to think about what that is, and where do you get that kind of disclosure is from your sheet, and we call it sheet. You're gonna get a dimension sheet, so when you draw, yeah, from your designer of course, and they will give it to you and you draw according to that. If you make it by your own, then you consult with your own design intern. Yeah. So here we're dealing with two views, introducing you two more new views. Okay, name. This we call it circular view, and that we call it rectangular view. In addition to your 6 views, yeah, we have 2 more views. So if you see like this with the circles and showing the circle, we call it circle views. All right, and if you're seeing the depth, all right, of your cylinders, then we call that a rectangular view. Okay, circular view showing circle from the top or the front, and this one from the side, yeah, from the side left, right. Sometimes can be also from the front or back, yeah. So it depends on your object. So anyway, so if it's showing, if your drawing is showing your cylinder depth, right, we're gonna call that view a rectangular view, right? So this is, you can see the rectangular view right here. All right, so here this is just an exercise. So what we want to do is you want to have to you have to determine which one is a top view, which one is a circular view, and which one is the rectangular view. So when you look at the top view, that is a circular view, and when you look at this front view, in this case they call it a front view. It can be also right view, who depends on the object of course, but in this example we mentioned this is a front view. All right, so this front view is actually your rectangular view. Okay, because it looks like rectangle, see, showing the depth of your cylinder. Here look, it looks like a circle showing the holes in your object. Yeah. So when you look at this top view, there's another exercise. Can you tell the difference between the hole and a cylinder? No, you can't, because we're just in a flat circle right there. You have no idea what's down there. Yeah, since this is the top view, you have no idea what's in the object. So it can be either a cylinder or it can just be a plain straight hole. Yeah, so this is a hole, and that's of course a cylinder up, right up. So we usually give the diameter of the hole in the circular view. See, this is the diameter of the hole because this is a hole going into, right, into the object. So in previous line, I told you, oh, we can't be able to determine what this is that the hole or is that the cylinder, and you have no idea, and you need a sheet to draw it, and we draw it, of course. So when you draw it, you have to label it. So this hole got to be a hole, right? So this circle is going to represent a hole. So therefore, we're going to use the note, yeah, and with the leader line right there, yeah. So diameter 20. And this one is a cylinder. It's supposed to be the cylinder. Your sheet said will make it a cylinder for this, right? Second circle. And that gotta be, okay, represented here, dimension with your linear line type, right? Which is your dimension type. And that's your diameter, 20 for this circle, representing cylinder. And you gotta draw it and you gotta label this dimension in your rectangular view, because you cannot be able to label that here in your circular view. Okay, so therefore for cylinder, you know, cylinder, you have already drawn a cylinder because your sheet said it so to draw a cylinder, and so you start dimensioning. In your top view you have a circle, so you will use circular view for showing the hole, all right, dimension of the hole. You're going to use a rectangular view to show the cylinder, okay, diameter. So you're not going to confuse, oh, this diameter, when you look at it, you know that is the hole because it is dimension in the circular view. You know, oh, this is the cylinder because you're dimensioning it in rectangular view. Okay, so be very careful right here. Don't get into repetitive features. Repeated. We call it just, even if the former name is repetitive, usually call it a repeated feature because you're gonna draw the same circle like so and so time. So here in this case, we're drawing the same circle, yeah. And here, of course, from here to here, you have a spacing of 15, meaning like from here to here, the distance is 15, and then from here to here, the distance is 15 times. You're gonna make it the repetitive circle, right? 10 of them. So from here to here, since one circle to the next is 15 unit, yeah, far away from each other. From here, the first circle to the last circle, you're gonna have 150 unit far away from each other, yeah. So 10 times 15. 15 is the distance between the two repetitive circle, and so we have 10 of them, okay. So therefore I have 150, yeah, distance from here all the way to the end circle. So you can see, right, in order for us to be able to dimension the repetitive, right, features, we use this little X symbol, right? And the X symbol, there's a space, of course, between the X symbol and the dimension. Your dimension is 15. You are repeating 10 times, so therefore 10 and then X, right? And don't put this X in the middle, yeah, between 10 and 15. This 10, your value, and then value mean how many times you're repeating that feature, and your repeat, right, symbol got to be, yeah, together, no spacing in between. So 10x, a little bit weird reading, but 10x and then 15. Yeah, here I am going 6, 8, 6 of my circles, and we're gonna go with the 15-degree, yeah, in between them because it is an arc right there. So where we're measuring the degree, right, plane is going to be your radius, and you will end right at the center of that two circles, yeah. So we have one circle big and another bigger circle. We're going to end at a common center, and the lines are going to come out, and you're going to measure the angle, yeah, and that angle is 15, and you will keep going, yeah. So here I put two lines right here for you. It's a little bit off, but it's okay. You can see it, yeah. So this is where the center is going to be right here. Yeah, so we're talking about this angle. So from here to that angle is 15. So you keep going across, and you're gonna have a angle of 15 each. You go when you draw the repeated feature on it. Yeah. This is just talking about your 6x, yeah, which I already explained on previous slides. So again, you use the x, no space, and then the value, yeah, 6 times of this angle, 15. Yeah. For your equally spaced on feature. So you have two things, yeah, repeat it, and this one is your equally spaced features. Repeat it, the same thing, yeah. We use about the same symbols, of course. It's just like the name is different, but the principle is the same, yeah. And this one equally spaced features. All right, so limited space. So if you have space like this, very limited, that you can't be able to possibly dimension in a regular way, you have to use unit method. Yeah. So this is called the jog dimension. See like how we jog it. So here is a jog dimension. Because it's really difficult to show the center of that arc right there in this part, yeah. So there is an arc center, so we have no difficulty drawing the center because it's either too huge, you know, of the part, or whatever the reason that it's difficult to put the center. Then we're just going to jog it and jog like that and put the center, yeah, somewhere. So that's we call it, since you're jogging, we call that a fault center. Yeah. So there's a fault center for this arc, and you're gonna dimension this way by using jog dimension. Jog dimension look like this, like a little Z, like a thunder sign. Yeah. Like the lightning sign right there. So since this is a fault center, you also have to jog, right? The dimension from the center to this surface, yeah, which is your plane. Again, from the center to that surface, which is another second plane. So you have two planes and an arc, and that's a 14, and that's a 56. Yeah, of course, it's not very. This is longer than that, but that's the way we jog and do a special dimensioning method. All right, so partially rounded. So we'll deal with the rounded ends and partially rounded ends. So this is completely rounded, and look at this. This is partially rounded. It's because this is a full, right, arc right here, about half of your circle, and this is like your arc is wide, yeah, your very very wide arc. So we call it partially rounded. It's not perfectly rounded, it's a partially rounded. And the radii, of course, we are going to label, yeah, or dimension this way. So you use a note, your leader line right there, and we have two arcs, so therefore I put it 2, x, and then radius, and then 7. Okay, the same thing, 2 x, and then your radius, okay, your arc. And here you do not put the value of the radius, and that's because, okay, it is fully, yeah, rounded. So for fully rounded ends like that, yeah, you're not gonna put the value for their radii. In this case, I have two fully rounded ends, so therefore I have like a 2 times r, yeah. Here, partially rounded, two partially rounded ends. I'm going to put my radii, and each one of them has a radius 7. Okay. Slots. So when we deal with the slots are like there's a slot like this is inside of your part. So slots we're gonna dimension by giving their overall dimensions. Okay, so we go again your extension line from here to here, from here to here, yeah. And I have like a 2, of course, you know, just by looking at it, it's a fully rounded ends of your slot inside of the object, yeah. And you also have, of course, from here to here is 10. Yeah, space is limited, so we're going to put our arrows out. Again, fully rounded, so radii is a given, but you don't have to put the value with it. We do exercise right here, and just like you got a dimension, your slot. Yeah, so we have a dimension from here to here, so we go. All right, the values will be given to you. So I'm given 40 for here to here. I'm given like a 10 from here to here. Space is limited, so I put my arrows out. Space is not limited, so I'm just go regular dimension. And here I have ends for my slot. Yeah, so they are fully rounded, so I'm just going to go 2 times and radii without the value. Yeah, so that's how you put all right, arc length. So here, the length of the arc is dimensioned in this way by using this arc symbol. Okay, so see this little arc over the value. So that's a 39. My arc is 39 units away from this end to the end. Okay, so here the same thing. We do all of it here. Yeah, symmetric symbol. That's a new one in this diagram. So you can see the little symmetric symbol right there. Okay, the symmetry is from here to here. Yeah, so this is kind of like serving as a mirror line for you. Yeah, so we'll throw the symmetric label on the mirror line right at the center, because you will have like a two, right, this side and this side equally have like exact features on each side. Okay, so we'll use a symmetry symbol to dimension. So from here to here is 18, from here to the center is 20, so you don't have to label the other part at all because they are symmetric to each other. And then from the mirror line to the end of that part is 30. Okay, so you only have to label your dimension one time. Yeah. All right, counter board. Counter board looks like this. Okay, when we draw it, of course, on the paper. Yeah, in your application, AutoCAD or other application for CAD, we're gonna draw just like that. Right, so counter board holes are specified by giving the diameter of the drill. Yeah, so here is your drill, and that's your diameter, and that diameter of the drill is given here, right? You can be able to see this outer circle and an inside circle, because you're dealing with, look at that, the first circle right there and the second circle right there. That's what we're drawing here. Yeah, if you look up closer from this side. So I have my drill diameter, I label this way. Yeah, so my first dimension with a leader line and a note. Now I have, look at this. This is your symbol. Yeah, you have your depth right there, and that's your counter bore. Yeah, so counter bore symbol coming into here. We know the diameter symbol. We know the depth suck. It's going in right here is 15, meaning like from here to here is 15. From here all the way to the end is 40. Okay, so the counter bore diameter, yes, this counter bore diameter is 20. Okay. And I don't want you to get confusion, and don't think like this is a regular circle, because it isn't. Okay, this is the entire thing from here all the way to the depth is a one note label. Okay, so one note dimension. So you know that when you look at it, you're dealing with a counter board. So when you draw on the side view or front view, you have to draw to the counter board, which is this shape. Yeah. So the drill is this guy, and that's actually this, but we don't put this label leader line right in there. Okay, we put a line right outside a circle. So the drill, this one is 10, that one counter bore diameter is 20, and the counter bore length go all the way down to 15. Okay, meaning like this depth of the counter bore depth, yeah, from here to here. So the head of the counter bore is not showing. Okay, so you have to measure 15 from the start of your drill all the way down. Yeah. So if you were given, right, the measurement, right, so which is your dimension of your part, you can be able to calculate the measurement from here to here, yeah, or the length from here to here, by subtracting 40 and then minus 15 of this depth, counterbore depth, yeah, so you have from here to here. Of course, in this example, it's not very proportional. All right, next one is the thickness of the material. So here, your depth is 25, yeah, and here giving you the drill is 10, and then the counterbore is 20. Of course, here we are showing the depth in our rectangular view, yeah. This is our circular view, so therefore you don't have to put the depth right there in this note. And why do we do this type of dimensioning method? It's because of the thickness of the material, yeah. Below that counterbore is significant, yeah. So therefore, you have to put it put the thickness instead of the depth, yeah. Here, in this example, your thickness isn't right, isn't significant, so only 15. Here in this, your thickness is significant because it is 25, yeah. So the thickness below the counterbore is significant, like 25. You're going to give that thickness instead of the depth, right? So therefore, the note, okay, the note for the counterbore dimension labeling is different, yeah. So here is your leader line, and we just give the drill and counterbore diameter right there, and then we're going to put the thickness diameter because it is significant right below your counterbore in the material, yeah. All right, so we use a countable hole. This is your countable hole, and to recess the heads of that bolt, okay, recess the heads of the bolts and the cap screw. So your counterbore, look at this feature, yeah, and we have of course a bolt into our counterbore. So when you drill right this bolt into our counterbore, you're gonna get this, yeah. So that's where we use the counterbore for, because we have to put the bolt right into that space, yeah. And then we'll get into the spot faced holes. So look at that, the like kind of like a cutoff, right? Counter bolt. So we call that the spot face holes. But the difference between a counter bore and a spot face, right, is that the machining operation happened to the counter bore. Yeah. So here is a curve right there. So like that is your machining on curve. Okay, so that's for the spot faced hole. Okay. Dimension, when you look at it, drill, countable, yeah. And from here to here is your thickness, yeah. But it's a significant because it's 10, yeah, out of from here to here, so that's pretty significant. So we give the thickness instead of the depth. Okay, countersink, how are we gonna dimension that? So look at this. Countersink is a little bit different in feature, yeah, feature than your countable. So look at that, yeah, that's we call it countersink. It's a very different feature right in there. So we do the same thing, yeah. Your drill diameter is 10, your depth going in is 30, yeah, from here to here is your 30. And then here, look at that. So this is your countersink symbol, right? Diameter 20, yeah. And we have an angle, yeah. Countersink angle is 90, yeah. So where's your angle is here, yeah, because it's like a totally 90-degree going in from this side, meaning like this thing is not some tilted one, yeah, not like this is straight 90-degree. I should draw a line for you so you can see the countersink on 90-degree right there, straight in. Okay, so if I tilt it like this, then you have a different angle. Okay, so we use the countersink hole. Um, this should be countersink actually. So anyways, a countersink hole, but I don't know why. Maybe when you write it countersink hole. Sometimes we call it countersink all the time. So anyways, a countersink hole is like this, and we use it to recess. Yeah, recess the head on your flat head screw. Yeah, so you instead of the bolt for counter bolt, you use a screw for countersink. Yeah. Okay. Chamfers. Alright, chamfers look like this, and then we're gonna dimension by using specific dimensioning method like this. So we're gonna have about like 45 angle, chamfer angle, and then we're gonna have 2 is your chamfer dimension, and then here you have a little uh, repeat, okay, because you have 2 of them here, one here and one another right there. So that's how we dimension the chamfer. Or you can also do 2 and then x and then 2, okay? So because you have 2 dimension here, 2 dimension here, so that's the first, that's the second. So first and second, 2 of them, yeah, like that at 45 angle. The measurement is 2 units, okay, from here to here. Here we have a little longer because it's 3 unit. So 3 unit 1, 3 unit 2, and your chamfer angle is 45, okay? Of course, when you look at it from here, it's going to be like you tilt the bottom chamfer to show 45, okay? It's pretty easy. It's like this plane and then that plane, okay? So when you see, you know that you can extend that plane out, yeah? On the non-material part, this is your material. So your material part is this is first plane and the second plane is 45 degree. Your first plane and the second plane has 45 degree. Okay, so you can either dimension this way or this way for your chamfers. And then drawing notes. So drawing notes, we use it all the time, yeah, because we want to give additional information, yeah. To complement your conventional dimensions for, of course, for the manufacturers. So manufacturer requirements, treatments, finishes, blanket dimensions. So all these things, we want to put them in our notes. So the notes look like this, okay? Then we usually put the heading note like that, and then N-O-T-E, all caps, yeah? And then semicolon, and then round, of course, whatever you want to note. So here we want to note all fillers and rounds at 3 mm and less otherwise specified. Second note is remove the burrs and break the sharp edges, okay? And we have like the applicable standards, and we're using ASME 114.5 2009, ASME 114.41 2003. Alright, we do a little exercise. So here, alright, you're given your drill and your counter board, countersink angle, all that, right? So this is we call a sheet, yeah. So you have your dimension sheets right there, and then we have to fill, yeah, in your drawings, yeah, in the feature side. So now I'm going to show you just one, right? So here, you have to dimension you're dealing with a counter board right there. So we're gonna get, I'm gonna do a 10. So I put diameter 10 for this, yeah. And then counter, this is counter board, so I use my counter board sign, yeah. And then I'm gonna go to my sheet and I'm gonna look at it. What's the counter board depth, right? And the counter board diameter. So I found diameter depth is 12. So I put my depth is 12 for my counter board, and then the counter board drill and max, all right, countersink diameter. So they're given like a 2, it can be counter bore or sink, and that diameter is going to be maximum 20. So I put that in here, yeah. So don't feel a little bit bad on looking at how right they write in the sheet. Yeah. So counterword drill and max countersink diameter. So this means for even if it's countersink or counterbore, you gotta give a max of 20 millimeter. Yeah. In this case, we're using the metric for the units, but you don't have to put that unit in here. We go unit less. Yeah, when we draw, because we're not keeping the same dimensions of your object outside. All right. Now we go into rules, strictly following ASME standard. So in this case, Y 14.5 M 2009. Okay, so we have like a 16 fundamental rules, and we're gonna learn all of that. Yeah. So let's see. So rule one is dimension should be arranged for maximum readability. So here are the rules. So the very first one is the spacing. Of course, these are sub rule for this big rule. Yeah. So this big rule, we're gonna get into spacing and readability. So in order to satisfy that, your dimension got to be arranged for maximum readability. Okay, meaning like when you look at your dimension, people can be able to read it clearly. Yeah. So in order for that to happen, this is what we're gonna do in our drawing. So the spacing between dimension lines should be uniform throughout the drawing. Okay, so make sure, because that like when you, of course, when you read it right from the bottom of the drawing, you can't be able to read that text. So it's got to be horizontal.